What's going on, everyone? Welcome back for one more video. Alright, our next video today, like I said, just walks through, I just wanted to work through a couple of different exercises with us just to illustrate this cost volume profit analysis and calculating break even and all this good stuff here. Alright, so I just want to work through two of them here, exercise 2136 and then exercise 2137. So I have the ebook pulled up here just so that we could see what the numbers are that I'll be using here for exercise 2136. Alright, so exercise 2136 here, it says, no slip company produces sports socks. The company has fixed costs of $91,080 and variable costs of 81 cents per package. It tells me here that each package sells for $1.80. Alright, so it wants me here to compute the contribution margin per package as well as the contribution margin ratio. Alright, so we could do that. I'll walk us through doing contribution margin and margin ratio, but then when it wants me to figure out this break-even point using the margin approach, I'll walk you through it real quick, but then I'm going to do it using the equation approach as well, just because I think it's a little bit easier, and I'll show you that we get to that same answer. Alright, so the contribution margin per package and the contribution margin ratio. So remember, the contribution margin per package is just the variable cost per package minus the the selling price per package minus the variable cost per package. Alright, so for this one, that would be $1.80 minus, how much was that? It was $1.80 minus 81 cents. Alright, so 180 minus 81 equals a 99-cent contribution margin per package. Alright, so that's my contribution margin per package. Remember, that contribution margin ratio is then just the contribution margin per package. Alright, so 0.99 divided by the selling price per package, or 1.80. Alright, that results in a contribution margin ratio. Let me do it over here, 0.99 divided by 1.80. That gives me a contribution margin ratio of 0.55, or 55%. Alright, so that's my contribution margin ratio there. Alright, it then wanted me to calculate break-even point using this contribution margin ratio approach. Alright, so I'll use the contribution margin ratio approach real quick. So remember, if I'm using the contribution margin ratio approach, then I'll just type the formula out on here. So it's fixed costs plus income divided by that contribution margin ratio that we just calculated. Alright, so looking back at my problem info, my fixed costs are $91,080, 91,080. Alright, plus I'm trying to calculate break even, right? So my income is 0. Then I'm going to divide that by my contribution margin ratio, or 0.55. Alright, so just running those numbers through, 91,080. Oops, no spaces in here, sorry. Divided by 0.55. That gives me a break-even point in sales. Remember, this is my dollar number here of $165,600. All right, if I wanted to break that down to units, then I could just take that 165,600 there and divide it by my selling price per unit, which was 1.80, and I get a unit number here of 92,000. So I have to sell 92,000 packages of, I think it was socks, right? 92,000 packages of socks here to be able to break even for a selling price of 165,600. All right, again, if I wanted to use my equation approach, I still can. So it would just be 180x minus 0.81x minus my fixed costs of 91,080. I'll set that equal to 0. All right, I can combine my x's. I'm left with 0.99x. I'll add 91,080 to each side, so equals 91,080. Alright, so I'm left with 91,080 divided by 0.99. That gives me that break-even point. Same number there, 92,000 packages. Again, if you wanted to then break it up to dollars, you could take 92,000, multiply by that selling price of 1.8, and you get $165,600. So the same result, just a slightly different way to calculate it or figure it out. Alright, so that's exercise 36. Alright, let's move on. Let's check out exercise 37 real quick before we finish up this video. So exercise 37 back here. It says owner Shan Mu is considering franchising her Noodles by Moo restaurant concept. She believes people will pay $10 for a large bowl of noodles. Variable costs are $5 per bowl. Moo estimates monthly fixed costs for a franchise at $9,000. So it wants me to use that contribution margin ratio approach again to find a franchise's break-even sales in dollars, and it gives me this check figure of $18,000. All right, I'm just going to go right into the equation approach here, right? All right, so I have 10x was my selling price minus 5x was my variable costs. So 10x minus 5x, my fixed costs there were $9,000. I'm trying to calculate break even, so I'll set it equal to 0. Alright, I'll combine my like terms here. I have 5x. I'll add 9,000 to each side, so it equals 9,000. I just do that quick math there. So 9,000 divided by 5 leaves me with 1,800 bowls of noodles here to be able to break even. It wants it in dollars, so I just take that 1,800 and I multiply it by 10. That gives me $18,000 as my break-even point in sales dollars. All right, so that's my answer for letter A. Check figure's good. I get to that same $18,000 that it gave me in the book there. All right, number 2 here. Number 2 says, Moo believes that most locations could generate $61,500 in monthly sales. And it wants to know if franchising is a good idea for Moo if franchisees want a minimum monthly operating income of $21,000. And then it says to explain my answer here. All right, so I got a problem with this one. My problem with this one is right now I have numbers that aren't like. I don't have like terms here that I can compare. I have one number that gives me what they expect that they could generate in monthly sales, and then one number which tells me what Moo expects their monthly operating income to be. All right, so I got two options with this problem. I could either take that $61,500 and I can convert it to an income number, or I can take that $21,000 of income and try to convert it back to a sales number. All right, so I got two options there for this one to try to make these numbers comparable. All right, so I'm going to take the second option. All right, just because it's easier to work with my equation, I could just set the equation equal to 21,000 and figure it out. All right, so the same equation as before: 10x minus 5x minus $9,000, and I'll just set that equation equal to that operating income number of 21,000. All right, I'll combine my x's. I have 5x. I'll add 9,000 to each side, so I have 5x equals 30,000. I'll do some quick math here. 30,000 divided by 5. I'm left with 6,000 units to be able to get to that income of $21,000. All right, so now all I want to know is if I'm selling 6,000 units, how much is that in dollars? So I just take that 6,000 units, I multiply it by the $10 of selling price per unit. That gives me $60,000. All right, so what I'm saying here, again, the number that I was using was that what she expects their operating income to be, right? So she expects their operating income to be $21,000, which means she expects that they'll have sales each month of $60,000. All right, now I can compare these numbers. All right, so Moo believes that most locations could generate $61,500 in monthly sales. So if they're saying that they want their operating income to be $21,000, which we just calculated, they could get to that $21,000 by having sales of $60,000. And Moo's saying that they should expect to have sales of $61,500. Well, that number's greater, right? She's expecting their sales to be higher than what their required monthly operating income will be. So I would say yes, franchising is a good idea. Franchising is a good idea because she expects their monthly sales to be higher than what their required monthly sales would be to earn that operating income of $21,000. All right, those are just a couple of exercises just to work through this cost, volume, profit analysis. Hopefully you have a little bit better understanding of this CVP analysis now. When we come back to class on Monday, we'll spend some time talking about how adding another product to this mix changes this whole analysis here. All right, we'll compute what we call multi-product break-even. Have a great weekend.